Hello, my name is Emmanuel Gumban, and my Rube Goldberg device performed two tasks: flip a piece of trash into the trash can, and also took a selfie on my computer. And this would not have been possible without some physics concepts, which I'm about to talk about. So the first one is the conservation of momentum. Now, the law of conservation of momentum basically states that whenever two objects collide in a system, the total momentum before and after the collision are equal. This is because the momentum is lost by one object and is gained by another. So in my Rube Goldberg device, this is well represented by the dominoes hitting the computer. Now, after the cracker box hits the marble box, this causes the dominoes to go down. Now, the dominoes have momentum, and it hits the computer, and the momentum is now equal to 0. So first of all, the formula for momentum is rho equals mass times velocity. Dominoes have mass, dominoes have velocity. As it's going down, boom, the momentum is now 0 because the velocity is 0, making the momentum 0 as mentioned before. So in this, the dominoes transferred its momentum to the laptop, conserving the momentum within this system. Now, the second concept we're going to be talking about is energy conservation. Now, energy conservation basically states that energy is neither created nor destroyed, but it can transfer from one form to another. So this example is well represented in my Rube Goldberg device by the dominoes. Now, the dominoes right now have potential energy, and in my example, a marble comes in and knocks over the dominoes. But in this example, I'm just going to use my finger. So I have energy in my finger, and my energy in my finger is going to transfer to the domino, and it's also going to transfer the domino's potential energy to kinetic energy. So, energy in my finger, transferring the energy to the domino, which transfers to another domino, showing the conservation of energy law. Now, the last concept we're going to be talking about is Newton's second law of motion. So, as everyone knows, it is force equals mass times acceleration. Now, in this specific case, we're going to talk about how both force and kinematics relate to each other. Now, kinematics deals with three things: position, velocity, and acceleration, and all of these are altered by force. So a good example of this is at the beginning of my device and at the end of my device with the marble box and an individual marble. So look at the equation, force equals mass times acceleration. First of all, we're going to rearrange it just to make it look like force divided by mass equals acceleration, because according to math, we can rearrange it. Anyways, this new equation is basically saying that a certain amount of force, for a certain amount of mass, you need a certain amount of force for the object to accelerate. Now, since this marble box has a lot of mass to it, it needs a large amount of force for it to accelerate. And if you look at what's going on, gravity is not the only force acting upon it, but we also have another force, which is the dominoes pulling it down, which is also affected by gravity, hopefully helping the marble box accelerate. If gravity and this dominoes being affected by gravity weren't forces acting upon the marble box, it wouldn't be able to accelerate as much. Now, at the beginning of my Rube Goldberg device, a singular marble was let go, and gravity was basically the force rolling it down. Since, according to the equation, since it's a smaller mass, there's not a lot of force that needs to be applied to this marble for it to accelerate, like so. Simple gravity causing it to accelerate, and the larger box needs a larger force, but in this case, there's only gravity acting upon it for it to accelerate, showing that concept of Newton's second law of motion. So there you have it, those three concepts that were explained: law of conservation of momentum, conservation of energy, and Newton's second law of motion. Thank you for listening.